Okay, this video is on the binomial expansion. It's a little shortcut to try and figure out some individual terms in the overall expansion of a binomial that was covered in the first section of this chapter. On a little bit of a tangent first, we got to cover. There's buttons on the calculator that will either look like NCR, or it might look like this with the N over R in brackets, or it could look like C and R, something like that, okay? And what does that mean? Well, that means the number of possible combinations, okay? So, for example, how many different ways can I order things, okay? For example, if I want to select 3 people from a class of 26, I have 26 people to choose from, I need 3. This is N choose R. 26, and I'm going to be choosing 3. 26 choosing 3. Now that can be written in the brackets, 26 over 3, just open brackets. And you put that in your calculator, find the button. It will give you 2,600 different possible combinations of different ways I can select 3 people from a class of 26. Total different scenarios, okay? The numbers are going to be quite large. Now just for, I'll get you to try this on your own. 4 choose 0, so put that in. 4, then the choose button, and 0, and that will give you 1. Do 4 choose 1, that will give you a 4. 4 choose 2, try that. Okay, that will give you a 6. 4 choose 3 will also give you a 4. And 4 choose 4 will give you a 1. Okay, so try those out just to get familiar with the calculator. Now I put this on purpose. Do you notice anything? 1, 4, 6, 4, 1. That's actually the 4th row of Pascal's triangle. Pascal's triangle, 1, 1, 1, 1, 2, 1. We're adding up the terms right above it. 1, 3, 3, 1, 1, 4, 6, 4, 1. This actual choose button, okay, which can be written, this could be written as 4 choose 0 and 4 over 1 in brackets like that. They actually give you the terms of Pascal's triangle, okay? It's a very interesting thing about Pascal's triangle and about the choose button. So Pascal's triangle could now be written like this. Remember, Pascal's triangle technically starts at row 0. So it would be 0 choose 0, then 1 choose 0, 1 choose 1 for the first row. So this would be row 0. This would be row 1, row 2, row 3, Pascal's triangle. And you're choosing, notice how they start at 0, and that would be my R values. Start at 0. So for example, if I want to find the 3rd term on the 5th row of Pascal's triangle, 3rd term would be term 3, but on the 5th row of Pascal's triangles would be 5. I'm actually going to choose 2, because it would go 5 choose 0 would be the 1st term, 5 choose 1 would be the 2nd term, and 5 choose 2 would be the 3rd term. And so if you did 5 choose 2 on your calculator, and every calculator is a little bit different, so you have to play around to find it. If you're using a graphing calculator, it's actually in the math button, or to PBR, and choose R2, and it'll give you a 10. And if you know Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. The 3rd term is a 10. Okay, but this is just a little shortcut way how to do it. All right, so how does that help us with doing the expansion? Well, there's a little formula that trying to figure out all the exponents and all that for the rest of the expansion. And it is T R plus 1 equals N choose R, A to the N minus R, B to the R. We'll go over all of this. Notice the difference between the R plus 1 and the R. And that was the whole thing because it starts at 0 on Pascal's triangle. So it's a first term, but my R value is 0 for 5 choose 0. Second term, the R value is 1. So there's always a 1 difference for that. So we'll go over how that would work. Let's take this expansion. 3x minus 1 over x to the exponent of 10. I want to find the first three terms. So term 1, okay, is going to go 10, choose 0. And then it's going to go 3 to the x, and it's going to go 10 minus 0. That's for my first term. My first term has an r value of 0. And then it's going to have the second term of 1 minus x to the exponent of 0. And so you can put this into your calculator. 10 choose 0 is actually just going to give you a 1. 3 to the x to the exponent of 10. Well, 3 to the exponent of 10 is 59049. X to the exponent of 10. And then this is, the second term is all the exponents of 0, so it'll just give you a 1. Okay, and so that is, therefore, that is the first term. The second term is going to go 10, choose 1. And be 3 to the x to the 10 minus 1. So it goes n minus r in the formula. And then it's going to go 1 minus, sorry, negative 1 over x. And it's going to go to the exponent of 1. Okay, remember your formula. T r plus 1, n choose r. First term to the n minus r, second term to the r. N would be your exponent in the Pascal's triangle, the row in the Pascal's triangle. And so you're going to have to do a little bit of work on that to figure all that out. Okay, so you can, let's see, 10, choose 1, and that is 10. And I want to have this all to the exponent of 9. And I want to have negative 1 over x. So I can have 3 to the exponent of 9. So I want to have 10 times 19,683 to the exponent of 9 and negative 1 over x. So I'm actually subtracting exponents here because I have the 1 over, I have the x in the denominator and I x to the 9. So my final answer is going to have x to the 8. And I want to have a negative times this number times 10. And that's going to give me negative 196,830. That is the second term. I would not be able to figure that out on my own using Pascal's triangle. That would take me a very long time. So this formula actually works a little bit easier. Okay, but be careful when you're combining here that you're actually subtracting exponents if you need to. And then you can do the same for the third term, term 3. And I'm not going to do a full expansion on that, but it would be 10, choose 2, because there's always a 1 less. 3 to the x to the 10 minus 2, negative 1 over x squared. And here, the squared would make that into a positive, and you have an x squared in the denominator, so I actually have to subtract by 2 in order to figure that out. Okay? Next example, find the 8th term of this expansion, the exponent of 15, without simplifying. So I'm actually going to, I can just leave it the way it is because the numbers are going to get massive until the exponent of 15. So 8th term, term 8 is going to go 15, choose 7. Okay, remember the formula, T, r plus 1 equals n, choose r, a to the n minus r, b to the r. My n equals 15, and my r equals 7 in this case, because it's the 8th term. So I'm going to have 4 to the x to the 15 minus 7, and I'm going to have my 2 over x, and it's going to go to the exponent of 7. Okay, so I didn't need to simplify, so I can just leave it like that. If you had to require to simplify, you'd have to be putting this in your calculator. You'd have the exponent of 8 going into both those terms, and the exponent of 7 going into both those terms, and you'd have to subtract your exponents. Last question. Finding, and these are probably the most trickier questions on this whole section. Find the coefficient of x to the 5 in the expansion of this. Okay? So that's going to take a little bit of work. I don't know what term number it is, and frankly I don't care what term number it is. But I'm going to have, so t r plus 1 equals n choose r, and I'm going to have my a to the n minus r, b to the r. Write my formula out first. Now I do know that n equals 10. Okay, that I know. So I'm going to have 10 and r. I do not know my r value. I do not know anything about it. I don't know what term number it is. I just know it has a coefficient, or it has an exponent of 5. That's all I know. I don't know where it is in the order. I know my a is just an x, my first term is an x, so I'm going to have 10 minus r, and my b is a 9, and it's going to be to the exponent of r. Now what I do know, like I said, I know it has an x to the 5. So what I'm going to do is this part right here has an x on it. Okay? So I want to take this component and I want to make it equal to the x to the 5. So the x to the 5 is going to equal x to the 10 minus r. And I want to solve this little equation trying to figure out what r is. Now, word of advice. Sometimes your second term will also have an x in it. So you'll have to include it in this little sub-equation that I'm using. My question said x to the 5. So anything with an x, I was going to make equal to x to the 5. And just so happened that it was only the one component I had to worry about. Sometimes you'll have to put both of them in here and you have an additional part to multiply in. That's okay. Now, from exponent rules, you remember if you have the same base on either side, you can cancel it out. So I do, and I have x's on either side, so I have 5 equals 10 minus r. Okay, so I'm going to have 5 minus 10 equals negative r. That gives you negative 5 equals negative r. 5 equals r. So that tells me that it was 10 choose 5. I'm going to have x to the 10 minus 5, 9 to the 5. And it asks for the coefficient, so I'm going to actually have to figure that out. So 10 choose 5, 252. I have x to the exponent of 5, and then I want to have 9 to the exponent of 5, which is 59049. Remember that from the previous question. Multiply these two together. That gives me a very large number. 14 million, okay, and so on, x to the 5. This is the coefficient. That is my answer that I was looking for. Let's do one more example. Bring out a piece of paper. Same idea. Let's find the coefficient. Let's say x to the 4. And I want to do, let's say, 2x plus 1 over x to the exponent of, I don't know, 8. Okay, and I'm just going to set this up for us. So I'd go, same idea, it'd be 8, choose r. I don't know what my r is. 2 to the x to the 8 minus r. And I have 1 over x to the r using my formula. And I can actually, what I'm going to do is I can do a little bit of simplifying inside here. So I'm going to 8r. I'm going to take my exponent and I'm going to multiply it into both these terms here. 2 to the 8 minus r, x to the 8 minus r. So this exponent I'm actually going to take into both of these things. I didn't have to in the previous one because I only had an x. And then I'm going to take this exponent, put it into both top and the bottom of this, and it's going to give me 1 to the r, x to the r. Okay? And then I said, like previously, you're going to set up a little sub-equation where you know you're going to have x to the 4, and it's going to equal anything that has an x on it. So that gives me x to the 8 minus r needs to equal to x to the 4, but also the 1 over x to the r. Okay, so I have a combination, both of these x's into their exponents, the outcome needs to be x to the 4, because that's what it was in the question, that's what it was asking for. So I take anything that had an x and say, okay, listen, my end goal needs to be x to the 4. So let's take these x's and make them equal to x to the 4. And so you can use your exponent rules. X to the 8 minus r, that is a negative r, that is an x to the minus r using the elevator rule. So now I can combine these. X to the 4 equals x to the 8, and when you're multiplying you add your exponents, so it's going to be minus 2r. And now I have a single base on either side. They're the exact same. Cancel out your x's. 4 equals 8 minus 2r. And you can kind of rearrange 2r equals 8 minus 4. 2r equals 4. r equals 2. I can figure out my r equals 2. And I can put it back into the formula I had. 8 choose 2 now. 2 to the exponent of 8 minus 2. X to the 8 minus 2. And I know my r, so I'm just putting it in 2 wherever these r's were. 1 to the 2, x to the 2. And you're going to do that. 2 to the exponent of 6. I want to have x to the 6. And I want to have 1 over x to the 2. You know that's going to give you some sort of coefficient to the x to the 4, and that's exactly what I was looking for. Whatever that coefficient is, was your answer. So this is using a little note using the binomial expansion formula. Okay, like I said early on in the note, remember that your term r plus 1 is going to be greater than your r in the general expansion because Pascal's triangle starts at row 0, okay, and term 0 on there. Okay, thank you very much.